Hello students, before this we have studied defects in the eyesight. In that which defects we have studied? Nearsightedness we have studied, farsightedness we have studied, presbyopia we have studied. These are the defects and how to correct or how to remove these defects, that one we have studied. So myopia will be there, hypermetropia will be there, or presbyopia is there, and in that we are using two types, or according to that defect we are using the lenses. Suppose nearsightedness is there, you are using concave lens. If farsighted is there, you are using convex lens. And in the presbyopia, suppose both defects are there, then you are using both lenses. So after this, next part we are going to study, and that one is there. Before starting, try this is there, and after that use your brain power is there. Like this way some points are there, and after that we are going to study some points related to uses of lenses, another uses of lenses. So in that first one will there is there, try this. First one is there, try this. What you have to try? So in this activities that are there, or try this is there, what you have to do? First thing is there, in your class many students are there, and many students they are using spectacles. So just you have to make the record of the students, how many students are having spectacles or they are using spectacles. Second thing is there, you have to note down the power. First thing is there, you have to notice, you have to record how many students are there using spectacles. Second thing is there, you have to note down the how many students are there, which power that spectacles they are using, or which lenses they are using. And according to that one, suppose we have studied before this, concave lens is there. Suppose what you have to do, first thing is there, you have to make the list of students having spectacles, using spectacles. Second thing there is, you have to measure, or you have to note down, record the power of the lenses or spectacles. You have to record the power of the spectacles, and from that you have to decide which defect they have. You have to note down which defect they are suffering. Suppose power is there, negative power is there, negative number is there, they are using concave lens. That means which defect they are having? They are having nearsightedness. Second thing is there, if their number is positive, power is there positive, then what you can say? They are using convex lens. And when convex lens is used, when there is defect, farsightedness. For that we are using convex lens. So this one you have to try this. You have to find out this one, how many students are having nearsightedness, how many students are having farsightedness. And after that, next point we are going to study in that one is the apparent size of the object. Next point is there, apparent size of the object. So what is the apparent size? So diagrammatically we will study. It is very easy. So one thing you have to do, or you have to see, next point is there, apparent size of the objects. Apparent size of the object. So in that apparent size is there. Apparent size in that what is there? Just see, one straight line will take, two pens you will take. Suppose two objects you are taking of equal height. Suppose here is there PQ is there, one object is there, same height, another object is there, another pen you can take, both height is there same, suppose height is there same, equal height is there, this one and this one height is equal, and suppose this one is there, P1 Q1 is there, and you are looking from here, suppose from here you are looking, suppose here is our eye, from here you are looking, okay, we are looking from here, then what will happen? This angle made by PQ is one object, first object is there, so this angle will be here, and suppose this angle you will take, this angle you will take alpha, and another one is there, angle made by P1 Q1, this angle will be like this, suppose this angle is there, and this angle will be this one, beta will be there, this one is there alpha, this one is there beta, so these two angles are there, and these angles are there of different object, PQ is one object, P1 Q1 is another object, and their sizes are equal, but see both objects are having equal size, but that object which is near to our eyes, that object is looking larger, even that another object is of equal size, but nearby object it is looking larger, and this is called as an apparent size of an object. So you might have understood this one is their alpha. So why that PQ is looking larger? Because angle subtended, see that PQ object is larger, object PQ looks larger. Why it looks larger? Because angle subtended by PQ with I is larger. So object PQ is looking larger. Why? Because angle subtended, angle made by this PQ with I, it is larger. And second one is that object P1 Q1 looks smaller. Why it is looking smaller? Because angle subtended. Now here which angle is there? Angle subtended, first one is there alpha, and here angle subtended beta. Angle subtended by PQ and angle subtended beta by P1 Q1. So angle subtended by PQ with I is larger, so object is larger. Here object angle subtended beta by P1 Q1 with I is smaller, and because of that, and even both objects, you can say size of P1, sorry, you can say, you can write here, even both objects are of same sizes, even their size is same. Suppose these two pens are there, we'll take like this way. Suppose these two pens are there and they are of equal height, but the pen which is towards me, towards my eyes, it is looking larger, and pen which is away from my eye, it is looking smaller. So same thing is there, like this way we are looking. So pen which is nearby my eyes, it is looking larger. Suppose it is PQ, and pen P1 Q1, it is even size of both is same, it is looking smaller. P1 Q1 is looking smaller. So this is This is called as a apparent size of an object. The next thing is there, use your brain power. Next point we are going to study, and that one is there, use your brain power. So you have to think and you have to give the answer. You need to use your brain power. Can you tell, can you recall, such activities are there, and in that you are getting extra information. So next point is there, and that one is there, use your brain power. Use your brain power. So how to use your brain power? Some points are given there. First thing, what you have to do, it is asked why there is need to bring that objects nearby to our eyes to see it clearly. So some objects are smaller, you have to bring them nearby our eyes, then you can see clearly. Why there is need to bring this object nearby our eyes? Because if you are bringing that object nearby our eyes, then angle subtended becomes larger. That object will look larger. Nearby, near point, it will look larger. Next thing is there, if we will bring that object more closer than that particular near point, that means closer than, less distance than 25 centimeters, then that object cannot be seen clearly. Even angle subtended is larger. Why it is not happening? Because near point is there 25 centimeters, and if that object is coming closer than 25 centimeters, then that object is not looking clearly. So because of near point, it is not looking clearly. Even angle subtended is there larger. So this thing you have to remember. So first thing is that to see objects clearly, we have to bring them nearby our eyes. We have to bring them nearby our eyes. And second thing is that if objects are brought closer than 25 centimeter near to our eyes, they cannot be seen clearly. Because objects closer than near point cannot be seen clearly. If objects are coming closer than near point, then they are not looking clearly. This one you have to remember. Even angle subtended is there larger. Even you can write here, even angle subtended by objects is larger. So this one you have to remember. And next point we are going to study, and that point is there, uses of concave lenses. So what are the uses of concave lenses? That one we'll see. So concave lenses, they are having various applications. In various instruments these lenses are used. In medical equipments these are used. In scanners they are used. In the torch they are used. In the torch also they are used. So in the peephole also we can see them. These are used. So next thing is the uses of concave lenses. concave lenses. So what are the uses? That uses we are going to study in detail. So first of all we'll discuss about that uses and then we'll write point. So first use is there, concave lenses are used in the medical equipments, scanners they are used, in the CD players also they are used. Why they are using these devices or in these equipments? Because these equipments are working on the laser light. Laser. So what is the long form of the laser? So laser is there, LASER, light amplification by stimulation of emission of radiation. Light amplification by stimulation of emission of radiation. So these instruments are using laser light, and to get clear images, we have to use concave lenses in these devices. Okay. Second point is there, in the peephole in the peephole we are using concave lenses. Now peephole, to inside your door, or when your front door is there, front door of the house is there, in that door is having one lens, one peephole is there, and in that peephole one lens is fixed, and that lens is the concave lens. So what will happen? You are looking through the smaller hole, but that lens will cover maximum area. Even any person, any thief is coming from outside, you can see through that peephole, that person whole as a whole, or you can cover larger area. So it is used to see outside from the peephole of the door, and for that concave lens is used. Third one is there, concave lenses are used in the spectacles to correct nearsightedness defect. Fourth point is there, concave lens is used into the torch to spread the light widely, produced by the small bulb into the torch to spread the light widely, and that light is produced by the small bulb into the torch. And the fifth point is there, camera is there, telescopes are there, microscopes are there. In these devices concave lenses are used, and these are used in front of the eyepiece or before the eyepiece. These are used in front of the eyepiece or before the eyepiece. These are used. These are the uses of concave lenses. So we'll write what are the uses of concave lenses. First point is there, concave lenses are used in medical equipments, scanners, medical equipments, scanners are there, CD players are there, CD players. Why? Because these devices or these equipments works on laser light. So you can take one scanner machine is there, suppose CT scanner is there or any, and in that you are using concave lens will be used, and here a person's body will be there. So what will happen? It will cover, that light rays will spread all over the body, and they will cover, they will take images. So for spreading the light rays, concave lenses are used. Okay. Second one is there, so in the peephole of the door, peephole of the door. So concave lens is used in the peephole of the door for the safety device, as a safety device, and it helps to look larger area outside the house. Concave lens is used in the peephole of the door because it helps to cover larger area and as a safety device. It is peephole. In the peephole camera you can say safety device. You are using it. Concave lens you are using. Next one is there. Third point is there. So concave lenses are used in the spectacles to correct the nearsightedness. Third one is there. Concave lenses are used in spectacles to correct nearsightedness. Correct nearsightedness. Fourth point is there, and what is the fourth point? In the torch also you can say torch. So concave lens is used in the torch to spread, what you can say, to spread widely light produced by small bulb of the torch. To spread widely light produced by small bulb. And the fifth point is there, and what is that fifth point is there? And that fifth point is in the camera, telescope and microscope. So in camera, telescope and microscope, and in the microscope. So why concave lenses are used? To get good quality images. So in the camera, telescope, microscope, concave lenses are used to get good quality images. These are the uses of concave lenses. After this, next point is there, and that one we are going to study, and that one is there. Uses of the convex lenses. Concave lenses we have studied now. Now we are going to study uses of convex lenses. Uses of convex lenses. Now, in that convex lenses, these are also having many applications. Wide applications are there, and in that we are knowing. In the simple microscope, convex lenses are used. In the compound microscope, convex lenses are used. In the telescope also convex lenses are used. In the correction of the eye defects also convex lenses are used. So many applications are there of the convex lenses. So one by one we will study. Next point is the uses of convex lenses. So what are the uses of the convex lenses? One by one we'll see. First use is there, you can say magnifying glass or simple microscope. As a simple microscope. In that one by one we'll study the points. So simple microscope is a convex lens, small convex lens of the small focal length. It produces erect, then a bigger image it is producing, virtual, erect and a larger image it is producing, but lens should be smaller and its focal length also should be smaller. So it is producing virtual image, erect image and bigger image or larger image. And such lens is called as a that lens is a converging lens, but you can say this one is the magnifying glass, or also you can say simple microscope. The next thing is that we can get an image larger than 20 times in the simple microscope. Any object will be there, that object's image we are getting 20 times larger than that particular object image you are getting larger. And what are the uses, where it is used? It is used by watch repairers, for the watch repairing, again for the testing precious gems and finding defects, precious gems and finding defects. So in that, first thing is there, first point we'll write. What is the first point? Convex lens of the smaller focal length. Convex lens of smaller focal length. Convex lens of the smaller focal length produces virtual, erect and a larger image. Second thing is there, such lens is called simple microscope or magnifying glass. Then third point is that simple microscope or that convex lens having smaller focal length, it is producing image of an object which is larger than 20 times larger than that of the object. We can get an image 20 times larger than object by simple microscope. Simple microscope. And next point is there, and that one is the fourth point is there. What is the fourth point? Uses. So who is using that one? Uses. Used for watch repair. It is used for the watch repair. Also it is used for the testing precious gems and finding defects. For testing precious gems and finding defects. Precious gems, jewelry, and finding defects. Finding the defects. And a diagram we can draw for the simple microscope. Suppose this one will be our principal axis, straight line will be principal axis. Then you will take one convex lens you will take. So how will you draw? I taught before this, like this way. Here compass and one arc, here will be your C1, and from another side also you will draw one arc, here will be your C2. Exact midpoint will be there, F1. So here you can write 2F1. Here exact midpoint will be there, F2, and here you can write 2F2. So what happens when you will keep object? What you can say, object will be there at a distance in between, here will be optical center. If object is there in between F1 and O, suppose object is here F1 and O, then first light ray parallel to the principal axis. After refraction, it will pass through the principal focus F2. Another light ray passing through the optical center, it will go like this way. But if you will extend these two light rays backward, and they will meet at single point, and this one will be image. This one will be image. Suppose A, B is the object, A dash, B dash will be object. No, sorry, image. It will be image. You can draw like this way. With scale, it will come straight. So it is giving what type of image? It is giving virtual image, virtual, erect, and magnified or larger. Magnified image is produced. But who is producing? Simple microscope. Simple microscope, or simply you can say convex lens. Convex lens. After this, next point we are going to study, and that one is there. Compound microscope. That one we are going to study about compound microscope. Its structure and working we are going to study about compound microscope. So in that compound microscope, two lenses are used. Two convex lenses are used, and they are fitted on the same principal axis. They are fitted on the same principal axis. There are two lenses. Which two lenses are there? One is their objective lens, another one is their eyepiece is there. Objective lens and eyepiece is there. So compound microscope. Compound microscope. So second use is the compound microscope, and in that compound microscope we'll see. So first of all, we'll draw a diagram, or first we'll take points and then we'll draw a diagram according to that one. So in that you can write construction, working and uses. You can write construction, working and uses. Like this we will take. So in that first we will take construction. In that construction, what you can write? Compound microscope. Compound microscope is made up of two convex lenses. Two convex lenses. Second point is there objective lens. Objective lens, and in that objective lens, smaller lens with what you can say, smaller focal length. Smaller lens with small focal length. Smaller lens with small focal length. Second thing is there eyepiece. Larger convex lens with larger focal length. Larger focal length. So next one is there 2 times magnification is produced. Magnification is produced. 2 times magnification is produced. So another thing is there, fourth one is there, 2 lenses are fixed or fitted on the same principal axis. On the same principal axis. Fitted on the same principal axis. And another one is there, fifth one you can say, two lenses are fixed into metallic tubes or metallic pipes, you can say metallic tubes or metallic pipes. So this one happens construction, this one is their construction. Actually we'll see now as per construction how it is working, these points you have to write first in the construction. Now I am going to rub this one, I am going to draw the diagram, and then I will give working and then uses. So these points you have to write diagram, and then you working and uses, how it works. So first of all, suppose one long line you would take, and it will be principal axis, then a smaller lens you will take, one smaller lens you will take. Suppose that lens is there, optical center is there. Suppose here F1 is there, so F1O, objective lens is there, so we are taking F1O. Second will be here 2 F1O, here will be F2O, and here will be 2 F2O. Why we are taking O? For objective lens, So what will happen now? Suppose you will keep object here, suppose object will be here in between F1 and 2F1. So first light ray parallel to the principal axis. After refraction it will pass through the principal focus. Second light ray, it is passing to the optical center. So after refraction it will go straight, but they will meet at single point beyond 2F1O. So here will be, this one is their object. Suppose AB is the object. Now here A dash B dash will be the object. Now here you are taking larger convex lens. You will take larger convex lens. So what will happen? Here will be optical center. Then, and larger